In this video, we're going to take a look at how to find the maximum and minimum turning points of a curve in terms of their coordinates, and also justifying which point is our maximum and which point is our minimum. So the first thing you need to think of when you think of maximum and minimums immediately is that dy dx at the maximum and minimum is equal to 0. Why is that? Well, if you take a cubic graph like the one we have here, this would be our local maximum, this would be our local minimum. And if I draw a tangent to that curve, meaning a line that touches off the curve at the maximum or at the minimum, and I was to look at what the slope of those lines are, you can hopefully see that there is no slope. That at those 2 points, the rate of change or the slope of the tangent is 0. What that means for us is that if we're given the equation and asked to find them, is we can use that concept. So I'm going to do it now. I've got y is equal to x cubed minus 9x squared plus 15x plus 2. If I get dy dx first, what will that give me? Dy dx will give me 3x squared minus 18x plus 15. And what I know is that if I'm looking for the maximum or minimum point, that dy dx, which is now this expression, that is equal to 0. And what I have here is a quadratic equation. Can I solve that? I can. So I'm going to divide everything through by 3, and I get x squared minus 6x plus 5 is equal to 0. And then I'm going to factorize it. And I have x, 5 and 1, and minus, and both of those factors multiplied together to give me 0. So that means that my x is equal to 1 and my x is equal to 5. And what we have here is the beginning of the coordinates for the maximum or minimum point. So what we need to figure out then is, alright, I have the x location, could I get the y location? And how will we do that? So we need to ask ourselves, is there some connection between the x coordinate and the y coordinate? And we do have a connection, and that is through the function or the formula here. So I'm going to take that for each value of x that I have and substitute in x. So in this first one here, I'm going to say I'll do it for x is equal to 1. And in each place where I had x, I'm now going to replace it with 1. And then tidying that out, I get 1 minus 9 plus 15 plus 2. 1 minus 9 is going to give me minus 8, 15 plus 2 is going to give me 17, and then minus 8 plus 17 is going to give me plus 9. So when I put in x of 1, I got out y of 9, so I'm going to have 1 and 9. I'm going to do the exact same procedure for my x is equal to 5. I'm going to have my formula. There's the formula, and every time I have an x, I'm actually now going to replace it with the number 5. So I'm going to have 5 cubed minus 9 by 5 squared by 15 by 5. When I work this out, what I get is minus 23. So there's my other coordinate. It's going to be 5, comma, minus 23. Now, those are the coordinates and the location of my maximum and minimum, but I don't know for sure which one I would label my maximum and which one I would label my minimum. So what comes into play now is the second derivative. So the second derivative, meaning d2y dx squared. So d2y dx squared is the second derivative. So how do I get that? I need to go back to the first derivative, which we have here, which is why it's so important that you're keeping track and using the correct notation the whole way down. So we've got dy dx is equal to that. So the second derivative is the derivative of this, which is going to give me 6x minus 18. What you can see from the second derivative here is that it still depends on x. It's still a function. And the reason why it still depends on x is because a cubic graph does have two turning points. So of course, the minimum or the maximum is going to depend on what x value you're at. There's two different points that we're looking for. So how do I use this d2y dx squared? Well, I'm interested in the x coordinates, as we said. We said it depends on x. So let me check out what does d2y dx squared work out to be if I take my value of x to be 1. So I'm going to have 6 by 1 minus 18, and that's going to give me minus 12. And what you will know and should know is that whenever d2y dx squared for a particular x value works out to be less than 0, you have confirmed that it's a maximum point. And the next one we are going to do is with the 5. So d2y dx squared is equal to 6 by 5 minus 18. When I do that, I'm going to get 30 minus 18, which gives me plus 12. That's greater than 0. If it's greater than 0, then we just confirmed that it's a minimum point. So what you can write then is that you had 1, 9, and that was our maximum. And we had 5 minus 23 as our minimum. And that's all we had to do.